I guess Akash, we are all set to start. Once we give the push, people will start logging in. I have just started the live stream also.
Okay.
We'll be starting in another 1 minute. We have delayed by 6 minutes. That is fine. We'll be starting in another 1 minute.
Okay, Shane. Yeah.
As we are joined by Nagendra from Shantiniketan. Welcome, President Nagendra.
Hi Nagendra, welcome.
I guess we can start it off now. We are at 5-7. In few more minutes, the number of audience will slowly pick up. By the time we can complete the formalities, I believe. So, with the president's permission, shall we begin? I hope I have not left out anything. All the meeting settings have been taken care of.
Sure, Shunanda, we can go ahead.
Okay. Thank you, President. Once again, a warm welcome to you all. Very good evening. Welcome to the session 3 of Project Anveshana. Here we are today to get to know a little more about recent research trends in agriculture. And we are really elated that today we have very honored guests with us, one of the fantastic administrator and wonderful resource person and scientist of Karnataka, we can say Dr. A.M. Ramesh sir. I have been very impressed by the works and the words which he has been following. And I will lead the welcome speech to the president, but I would wish to welcome you all once again today to this wonderful event. And I request our treasurer, Rotractor Bindu, to administer the rotary four-way test to us before we could initiate the program. Over to you, Rotractor Bindu.
Yeah, Srinidhi. Good evening, all. It's my privilege to administrate to you all the rotary four-way test. I adhere you to all the rotary four-way test. Kindly repeat in your mind as I recite it. The four-way test. One of the things we think, say, or we do. It is truth. Is it the truth? Is it fair to all concerned? Will it build goodwill and better friendships? Will it be beneficial to all concerned? Thank you.
Thank you, Rotractor Bindu. I now invite our president, Rotractor Lavanya, to give the welcome address. Over to you, Lavanya.
Thank you, Shunadi. Good evening and a very warm welcome to you all on this pleasant Sunday evening. The very first session of Project Anveshana was regarding data science, as it was one of the trending domain of the tech industry. So, it was a great success, and then with that Project Anveshana, which was followed later on by most demanding technologies in present era. So, session 2 of Project Anveshana was regarding drone technology and innovation. That was also a huge appreciation that we received. So, coming to today's Project Anveshana session, it's all about recent research trends in agriculture. Well, it's my privilege to, it's my immense pleasure to welcome you all to session 3 of Project Anveshana, a session on recent research trends in agriculture, organized by Research and Innovation Committee of Rotary Club of Bangalore, Sheshadipuram, and in association with Royal Concord PU College, Kalyanagar, Bangalore, and Karnataka Science and Technology Academy, Government of Karnataka, and which is being supported by Rotary District Occasional Service Team, RID 3190. So, on behalf of all the members of Rotary Club of Bangalore, Sheshadipuram, I welcome the chief guest, Dr. A.M. Ramesh, CEO of Karnataka Science and Technology Academy. A hearty welcome to you, sir.
Thank you very much.
It's my privilege to welcome another chief guest of the day, who's none other than our very own Young and Energetic Club Advisor, Rotarian Meera ma'am. Warm welcome to you, Meera ma'am. I welcome the guest of honors, Dr. Balasubramanian sir, Principal of Royal Concord PU College, Kalyanagar, Bangalore, and Rotarian Dr. Radhakrishna sir, who is always supporting District Director of Occasional Service, RID 3190. And I would like to welcome the speaker of the day, Mr. Abhishek Kulkarni, Agriculture Research Scholar. Happy to have you all among us. A very warm welcome to you all. I welcome our immediate past President Retractor Srinidhi. A very warm welcome to you, Srinidhi. I welcome the past President Retractor Apurva, and I would like to welcome Project Chair of Anveshana Retractor Akash and Coordinator Retractor Manasa Gowda. Very warm welcome to you. And very warm welcome to all the directors and members of Rotary Club of Bangalore Sheshadipuram. And very warm welcome to all the past presidents and secretaries of other clubs, and to all my fellow retractors, non-retractors, invitees, guests. A very warm welcome to you all on this pleasant Sunday evening. Happy to see you all and wishing you a very happy learning ahead. Thank you, and over to you, Shanadi.
Thank you, President. Welcome to you too. I'm very elated to see our home club Rotary President, Rotarian Vincent Raj sir here with us. Warm welcome to you, sir. Thank you so much for joining
Sorry to
us.
not recognize. Very warm
Thank
welcome
you.
to
No
you,
issue.
sir.
It was
Also,
agriculture, so I was very interested. Thank
Yes,
you.
sir. We are very, very happy to have you here with us. And I also wish to recognize the presence of our past President Retractor Krishna Arjun, past President Retractor Nishit, who has joined here. So thank you so much.
welcome past President Krishnarjun and welcome past President Nishant. Thanks for joining.
So as we say, agriculture is the backbone of India, and our session 3 on Project Anveshana, we wanted to touch upon this particular topic on what are the recent trends which are taking place in the field of agriculture, so that we can gain more knowledge on it. So, more to speak about Project Anveshana, it was initiated by Research and Innovation Committee of Rotary Club of Bangalore, Sheshadipuram. It's a monthly session on several recent research related topics, and we are here today with the wonderful chief guest. I request the Joint Secretary of Rotary Club of Bangalore, Sheshadipuram, Retractor Rakshit, to introduce our chief guest of today, Dr. A.M. Ramesh sir. Over to you, Rakshit.
Good evening, everyone. Dr. A.M. Ramesh, MFSC, PhD, Chief Executive Officer, Karnataka Science and Technology Academy. He is a graduate from University of Agriculture Sciences, Bangalore, with BFSc in the year 1987 and completed MFSc in the year 1989. Subsequently completed PhD in Aquatic Sciences from the University of Agriculture Sciences, Bangalore in 1995. He then completed Bachelor of Journalism offered by ICFAI University in 2010 and Diploma in International Environmental Law offered by the United Nations Institute for Training and Research in 2011. His professional experiences are research associate at the Department of Aquatic Biology, College of Fisheries, Bangalore for 4 years, project manager in private industry for 4 years, scientist at Karnataka State Remote Sensing Application Center, Bangalore from 2001 to 2007, coordinated projects related to integrated coastal zone management for Karnataka and MTech Geoinformatics program offered by KSR SAC in association with the Vishweshwaraya Technological University and Survey of India, Government of India. Senior Scientific Officer in the Karnataka Science and Technology Academy, KSTA, Department of Science and Technology, Government of Karnataka from May 2007 to March 2018. Chief Executive Officer in the Karnataka Science and Technology Academy, KSTA, Department of Science and Technology, Government of Karnataka since April 2018 to till date. A hearty welcome to you, Dr. Ramesh, sir.
Thank you very much, Rakshit.
Thank you, Dr. Rakshit. I now hand it over to Dr. A.M. Ramesh sir to address us and present his speech to us. Over to you, sir.
Thank you very much, Mr. Srinidhi. Namaskara ellargo. Good evening, all. At the outset, on behalf of KSTA, I welcome you all to this particular webinar. President of Rotaract Club, Ms. Lavanya, Research and Innovation Committee Chair, Rotarian Rotaract, Mr. Akash Shetty, Chief Guest, Rotarian Meera Bai Shankar Madam, Guests of Honor, Dr. Radhakrishna, Dr. Balasubramaniam, today's young speaker, Mr. Abhishek Kulkarni, my friend Professor Srinidhi, students, teaching faculty, and all the participants. In fact, KSTA is very happy to join with Rotaract Club in organizing this particular webinar. When Dr. Srinidhi inquired with me, in fact, I was delighted. We had not organized any programs in association with either Rotaract Club or Rotarian Club before. So it's a good sign that we are joining hands with Rotary Club also. In fact, I am very privileged to be present on this particular occasion. Mr. Abhishek will be delivering a talk on recent research trends in agriculture, which is of topical importance for this particular decade. Now, let me briefly highlight the activities of Karnataka Science and Technology Academy. Karnataka Science and Technology Academy was started in the year 2005 under the chairmanship of distinguished space scientist and former chairman of ISRO, Padma Vibhushan Professor U.R. Rao. Now, the present chairman is Professor S. Sayappan, who was the Secretary, Department of Agriculture Research and Education, and Director General of ICR. Since May, he has been the chairman of KSTA. In fact, KSTA was started with an objective of promoting science education and also bringing about awareness among general public. In this pursuit, we have been organizing a bouquet of programs across the state. We have covered the entire educational pyramid. That means from high school level to the entire university level, we have various programs across. As I told in the beginning, we have conducted some 31 conferences in the last 14 years. And not only in Bangalore, we have covered North Karnataka also. In Bangalore, we have organized 8 conferences, in Gulbarga 6, and in other places, 1 or 2 conferences we have organized. Apart from this, we have also organized many training programs and workshops across the state. In fact, we have covered the entire state. In all the districts of the state, we have organized one or the other programs. Then we'll be very happy to associate with Rotaract Club in future in organizing such webinars and programs. The topic, as I told, agriculture is very important. I must compliment the Rotaract Club for choosing this very important subject. India is self-sufficient today because of Green Revolution. In early 1950s and 40s, there was deficiency in food, and hunger was the main issue then. Then Professor Swaminathan, along with father of Green Revolution, started this particular thing. In fact, William Gord was the person who coined the name Green Revolution. Norman Borlaug is considered as the father of Green Revolution. In India, of course, Professor Swaminathan is responsible for making India self-sufficient in food. We are happy that we are self-sufficient from a ship-to-mouth existence. We are self-sufficient now. And our Abhishek will be highlighting how well we have come up in agriculture so far and what are the recent trends that we are pursuing in agriculture. In fact, Professor U.R. Rao always used to say, agriculture in India has to develop even further. In fact, I will tell one short anecdote that used to always say. It seems when Professor Rao visited US, he was invited for a farm. As you know, in US, agricultural farms are thousands of acres big. And he was invited to South Dakota for seeing the agricultural field. When he was going with the farmer in a tractor, he was using satellite remote sensing data, it seems. Then the farmer asked him, Professor Rao, do you know which satellite data am I using? Seems Professor Rao told, you must be using US satellite data. Then he told, no, I'm using your IRS-C1 data. At that time, India had a remote sensing satellite, and it used to give satellite data. And India was not using, but abroad, people in US and other countries were using it. He was always lamenting that our farmers are not being able to make use of our own technology, whereas advanced countries are making use. As you may be aware, now we have launched the Cartosat 3, which has a spatial resolution of 0.25 meters. Spatial resolution in the sense, any object bigger than 25 centimeters, one can see on the image. Such is the capability of our technology. I am sure in the coming days, our people will be able to use our own technology and grow more food. Mr. Abhishek will be throwing more light on these aspects. With this small brief talk, may I thank all the participants, especially my friend Mr. Srinidhi, for inviting me. In future, KSTL will be happy to join hands with Rotaract Club in organizing many such science popularization program. Thank you very much.
Thank you so much. We deem it an honor, sir, that we got an opportunity to associate with you. We have been always thinking that we need to grow higher, and you provided us an opportunity to get associated with you so that we can get some more exposure and grow higher. And thank you for this presence. Thank you for the support and this wonderful address which you provided us. And we are very sure and we are very happy that the current science and technology revolution which is taking place in India will take us forward, way forward, and help us grow further in many more days ahead. So with this, once again, I would wish to thank Dr. A.M. Ramesh sir and also the Karnataka Science and Technology Academy for supporting us in this particular project. Thank you. Thank you so much.
Thank you very much.
Thank you, sir. It is now my privilege and an honor to introduce a very young person who is with us and a very young and energetic person. Very rarely we request ma'am to be the chief guest because always she is there with us as a guest, not as a guest, but more so as a member of our club and being a support to us. But we very badly wanted ma'am to address. So before I could invite Rotarian Mirabai Shankar ma'am to address us, I wish to introduce her to our gathering here today. Rotarian Mirabai Shankar, born in 1939 at Coimbatore, she studied at Presidency College in Madras. She claims that she is the least educated in her family, having a gold medal in both MA and BA at that point of time. She entered into the field of service along with her husband, late Rotarian Shankar sir, who was a past president of Rotary Club of Bangalore. In 1982, she was the secretary of Innerwheel Club of Bangalore. In 1984, she was the president of Innerwheel Club of Bangalore, and she started a charitable trust during her secretariat period and Innerwheel Club Scholarship Trust during her president period. She is known for her Raila experience for more than 30 years, and she has a company called Panchal Technology, which was started in 1974. Her son, Dr. Banu sir, and daughter both are abroad. And son is a computer scientist, and daughter is an educationalist, and her daughter-in-law was invited as a panel member by UK government for a summit. And even at this age of 81 completed, she still runs and owns her industry. And as far as I am knowledgeable, her company is the very unique company in all over India and producing one of the most unique product. So we are very happy to have our club advisor and trainer, Rotarian Mirabai Shankar ma'am, here with us as a chief guest. I hand it over to you, ma'am, for your address.
Can I start, Srinidhi?
Sure,
Can
ma'am.
I? Yeah. It is not my daughter-in-law who was invited to UN. It is my granddaughter.
Priya, yes, yes.
Yeah. Okay. Hello, my dear young friends. You are all very young. The chief guest and even Taliva, that is Rotary President, everybody is younger than me. So all are young friends only. Since my Lord changed his residence 6 years back, I have a disconnect with farmers and field visits. I am not a technologist. I am only in the agriculture input industry. I was an understudy to Mr. Shankar and learned from his experiences. He was an agricultural technologist and a dreamer. All scientists are dreamers, otherwise they can't innovate. Okay. From the ancient days, women were the farmers and men the hunters. Even now, lots of women are employed to do agricultural operations in unorganized sector. As in other fields of employment, all over the world, they are not paid equal wages as their counterparts men. Raising a red flag apart, apart in 2 minutes, I will put forward wherever there is sunlight and water, something has to grow and will grow. What we don't want, we call it as weeds. The important factors are the soil, climate, and water. Farmers should select a crop which is suited to the above mentioned factors, which is in the Almighty's hands. What has to be the farmer's effort? Select a suitable crop, look after its needs, water, nutrition, major and micro, especially water management, conserving water. We have technologies, digital interventions, and innovations, climate smart agriculture, resource management. Strengthening the farmers' community is vital. These are my general thoughts. Thanks for the patient hearing. Jai Kisan.
Thank you, ma'am. You kept it really very short. Just to get a little more knowledge about your experience in the field of agriculture, you mentioned us that right now you are not in touch, but we are well aware that you had been working with the agricultural field and the fertilizer industry for a pretty long time. Would you like to share some experience with respect to how your journey in the research of your product went ahead during those days?
Patent of the product is Shankar's. I'm only an understudy. I worked along with him and I have traveled all over South India along with him to the farmers' fields and all. Farmers are a very likable lot and they are intelligent. They are intelligent. You say something, they think about it. We should not uh, think village people or farmers or something not that much. They are very kind people. And when we say something, I have gone into the fields, got into the fields, and as I'm telling you, I was an understudy. And he has the patent and I market it. That's it. He was a dreamer. He was a dreamer. He was not interested in money. Even I am not that great. What do I say? A desire to accumulate wealth. Everything has to flow. Knowledge has to flow. Water has to flow. Air has to flow. And our love has to flow. Otherwise, it becomes stale. And farmers, they are very receptive. They are very receptive. And we call farmers the men folk, but you must see the women folk, how they attentively listen to you and absorb things. We should not underestimate the lady farmers, the lady workers who work in the field. And I have great respect for all the men folk, okay, women folk who are employed in the in growing of crops and looking after things. Salam to them.
Thank you. Thank you so much, ma'am. Thank you for your address today here with us. We are very proud that we could hear your journey and your impressions on the field of agriculture. Thank you so much once again on behalf of RCBS. I now invite our Research and Innovation Committee Chair, Protractor Akash Lakshati, to introduce today's guest speaker, Mr. Abhishek. Over to you, Protractor Akash.
Thank you, Srinidhi, for the opportunity. A very good evening, everyone. It's an honor and a great pleasure for me to introduce our speaker today, who is going to talk us about a most inspiring topic, recent research trend in agriculture. Mr. Abhishek Kulkarni, born in the year 1998, he completed his BSc in Agriculture from University of Agriculture Sciences, Bengaluru. He is pursuing Masters in Agriculture. His main technical expertise is in agriculture-oriented technologies, genetics, and plant breeding from UASR. Mr. Speaker is a passionate and enthusiastic orienter. He is the co-founder of Be the Change Hospet, an initiative by the Cognition Social Innovation and Research Center Hospet, which deals with urban food waste and management. To speak about awards and achievements, he received various awards at state and national. He won a medal at National Agri Unifest held at Tirupati in the year 2018. He was one among to speak for India Debate Competition in the year 2017. He was a recipient of second Best Startup Award in Agriculture during PG Science Week at GKVK Bengaluru in 2019. A heartily welcome to you, Mr. Abhishek. Thank you. I
Thank
hand
you,
over
Akash, for your kind introduction. I'm humbled.
Thank you, Mr. Speaker. And I now hand over to the Srinidhi.
Thank you, Protractor Akash. Thank you for your leadership in getting this project done. We are very eager to listen to a very young speaker to speak about Abhishek Kulkarni. As far as what I know him, I got to know him through my cousin, and I had just got to know him as a friend, but later on I got to know the orator in him and the way he addresses and the speeches which he has given, the competitions which he has participated in. So, young achiever of our state, we can say. So, over to you, Mr. Abhishek. We are eager to listen to you, and we will very keenly listen to the aspects which you're going to talk to us about.
Thank you, Professor Srinidhi. A very pleasant good evening to one and all present here. Dr. A. Mirabai Shankar ma'am, and all the other dignitaries. It's my pleasure and an honor to be present before you and deal with the topic given to me. Recent research trend in agriculture. I think my screen is visible to everyone.
Yes.
Before starting my presentation, that is recent research trends in agriculture, I want to know, let me say what agriculture is. We all know what agriculture is, right? Agriculture is a art, science, and a skill of growing that commodity, which we need at least 3 times a day, 7 days a week, and 365 days a year. That is the food. When we see the historical aspects of agriculture, agriculture is not new. For around 10,000 years, human has been farming on the earth. To put it in Dr. M.S. Swaminathan, he's the father of Indian Green Revolution. Future belongs to the nation with grains and not guns. Guns we can purchase, but grains surely we cannot purchase. We have to grow on the earth and this very soil only. Therefore, agriculture has played a very major role in the human aspects. So now let us understand why agriculture is important in the form of the great Indian agricultural story. Farming is the first profession taken up by humans, thus giving rise to civilization. And my dear friends, we should know that India is the home for the first civilization in the world, that is Indus Valley civilization. So it is farming which taught humans the civilization on this earth. India is the center of origin for highest number of cereals and pulses. My dear friends, India is blessed with around 20 agroclimatic zones, a varied agroclimatic regions. We have the Thar Desert, we have the Western Ghats, we have the Himalayas, we have the Deccan Plateau. And believe me, no other country in the world is as blessed as India is, because you can grow any crop in India. Literally any crop can be grown in India. That's the agricultural heritage we got for our country. When we look up at the statistics, the land under cultivation in India is at 157.35 million hectares. I'm again stressing land under cultivation is 157.35 million hectares, and India holds the second largest agriculture land in the world. Around more than 50% of our dependent on farming and other allied sectors. That's around 70 to 80 crore people. So 70 to 80 crore Indian human resource is into the novel profession called agriculture. So 15% of the GDP is from agriculture, and also a considerable export value. Our basmati rice, the spices of Kerala are well known in the European market, and that's why Britishers were attracted towards India because of that rich agricultural heritage. Another point to mention here is during lockdown, which was 2020, all sectors showed negative growth. It was only agriculture sector which registered a positive growth of plus 3%. So anything can go down. IT can go down, BT can go down, but agriculture will survive all the odds. Yet we all neglect and turn down this sector. So now let us break down the misconceptions and understand the latest trends in Indian agriculture. My dear friends, over the time, there has been a vital transformation in the agriculture sector too. I would like to present my views under these 4 points, where I shall be bringing out all the trends which have been happened in the past 10,000 years, which is happening in the present. And I would also like to predict the revolutions which will assure food security for the next 10,000 years to come. So I would like to divide under these 4 concepts: green revolution to gene revolution, from subsistence to startups, from migration to micro entrepreneurship, from Pusa to Pura. So let us dive into the recent research trends in agriculture. My first, I'll be touching upon from green revolution to gene revolution. As rightly mentioned by Dr. M. Ramesh, green revolution is how India doubled its food grain production in the 70s. My dear friends, to understand the recent research trends, we have to know about what has been done, so that from there we can connect the dot and understand the recent trends. In that issue, I would like to also quote the gene revolution, which took up in late 90s and early 2000s. That is the gene revolution. How genetics and biotechnology changed the shape of Indian agriculture in late 90s. I'd like to mention here that green revolution doubled the Indian food grain production through novel technologies imported from the Western world, while gene revolution, or the BT cotton and other gene revolution technologies, helped us to overcome very vital pest and disease problems, which caused a very serious yield losses. That will be touched revolution. Then organic farming and many more, the way ahead for the millennials. As we know, it's the age of millennials. There are bigger challenges also in ahead of millennials. Let's touch upon what are all the way ahead for the millennials too. Then green revolution. As I already said by Dr. A.M. Ramesh, we had ship to mouth existence soon after independence and prior to green revolution. What was this ship to mouth existence? It's very hard to believe, but it is truth that India was grow its own food sufficient for its population. We were deficient of food. There was a food deficiency everywhere. Therefore, we dependent on the food which came from the ships. I'm sure Meera ma'am and Ramesh sir would relate to the fact that way back in 60s and 70s, the PDS system had the wheat coming from America or the Mexico. That was our fate during the post-independence, and that was because of the cruel rule of Britishers also. So to overcome this problem, in the 70s, government imported dwarf and semi-dwarf varieties from America and Mexico. As directly said, Dr. Normani Borla, He worked at the Mexico Institute, where he developed novel dwarf and semi-dwarf varieties of wheat, and rice was from Japan, where we got the semi-dwarf variety. These two, to be precise, those were Kalyan Sona and Dharma Roja. These are all the varieties which we got. We imported these varieties from America and Mexico, and then we crossed this with the locally available rice and wheat. What was the result? It gave to high yielding varieties. So what the farmer was able to grow in 1 acre of his farm, he was now able to produce the double of the farm produce. That solved the food crisis of in 1960s and 1970s. And also it was because of the introduction of fertilizers. Highly energy efficient fertilizers in the form of urea were introduced in the Indian agriculture. It was the same time when the Seed Corporation of India was established in 1963. The IFCO, the largest cooperative of the Indian Farmers Fertilizer Cooperative, was initialized in 1967. So 1960s and 70s was that golden age for Indian agriculture, where we were able to double our production. Through these statistics, it's clearly visible that our rice yield, which was at 20,000 tons, was doubled to 40,000 tons in mere 20 years. This was the magic of Green Revolution. All thanks to normally Borla and Dr. M.S. Swaminathan. Then came the gene revolution. What was this gene revolution? In the late 90s, due to the advent of many biotechnological tools and gene editing tools, scientists were able to alter the genes of the plants itself and insert the foreign genes for higher yield. What happened in Green Revolution was we followed the traditional breeding procedures to improve the yield. That's it. We were not altering any genes or adding or altering the foreign adding or altering the foreign genes in the plants. But by late 90s and early 2000s, scientists were able to develop such biotechnological tools which enabled them to do the genetic engineering and insert the foreign genes for higher yield. Thus came the advent of BT cotton. BT cotton stands for BT stands for Bacillus thuringiensis, which is actually a bacteria. The gene of that bacteria was isolated and inserted into the cotton to give the resistance against a very important pest called as the bollworm, Helicoverpa armigera. It's a bollworm which attacks the cotton crop and causes significant yield losses. To overcome this constraint, we were able to produce BT cotton, which ensured that there is no loss of yield due to this bollworm or Helicoverpa armigera. So pest and disease resistance was incorporated due to the BT genes. There are 3 genes: Cry1 gene, Cry2 gene, and Cry3 gene, which were inserted into the cotton crop, and that's how we got the resistance against the pest of the cotton. So here in this statistics, you can clearly see the area under BT cotton has now almost reached 95 to 96%. But there is small drawback, that's the biosafety issues with BT in food crops. In India, there is a committee called GEAC, Genetic Engineering Appraisal Committee, without the consent of which we can't introduce BT crops. Dr. A.M. Ramesh must be knowing there are so many number of BT crops in the cold storage of universities which are ready to come, but GEAC is not approving because of the biosafety with BT in food crops. In USA, there is BT corn. In USA, there is BT soybean. Herbicide tolerant soybean is also present in USA. But in India, as of now, there are no food crops. A cotton is a commercial crop which will not eat. Therefore, no problem with the biosafety issue. But when comes to the food crops, we have BT brinjal, and a ray of hope we can say is that in last year 2020 they have given permission for field trials of BT brinjal. So it's not too far when we'll be having BT brinjal and BT mustard in our food chain, but yet there are certain biosafety issues regarding BT food crops which on which scientists are working to overcome that issue also. Then my core, that's the core of my topic today, the way ahead, potential future disruptions. These are the disruptions which are going to change the shape of the Indian agriculture in the near future. That is organic farming, integrated farming system, hydroponics and hydrogels, aeroponics, remote sensing and geoinformatics, IoT, Internet of Things, precision agriculture and nanotechnology, crop modeling and biofortification, and biofuel. All these hold the key for the success of agriculture in the near future. As I already said, agriculture is not new. We have been tilling the farm for past 10,000 years, and it will continue for the next 10,000 years. These are the recent research trends which are going in the form of agriculture. And I'm happy to mention, as already mentioned by Dr. A.M. Ramesh, remote sensing and geoinformatics are taking place in the field of agriculture. I'll throw a light on that. I was made to understand that many PU students are attending this. So for them, I'm just going to introduce each topics, because each one of these topics requires a whole session to make you understand. So I'll be introducing you to all these topics one by one. So now let us dive in and see what are all the future potential disruptions. Organic farming. I call organic farming as a gateway for sustainability. And my dear friends, organic farming is not new to us. We have been following organic farming since the Vedic age. But why now again it has taken place? That's because of the changed behavior in the human agriculture and also human psychology. So what's organic farming basically? Organic farming is, to be in very simple words, it's no use of chemical fertilizers or any fertilizer, any things which are hazardous to the planet or the environment or the ecology. Then all those strategies which fulfill the following conditions. So for a technology or the organic farming, these four technologies these four conditions have to be fulfilled. That is eco-friendly, economically viable, socially just, and humane. If all these conditions are fulfilled, then that can be taken under as organic farming. So here are few examples of components of organic farming. That is biofertilizer. As I already said, in organic farming we don't use chemical fertilizers. So what's the alternative for chemical fertilizers? The alternative for chemical fertilizers is biofertilizers. These are novel strains of microorganisms like rhizobium, azotobacter, and azospirillum. What these bioorganisms or microorganisms do? See, majorly there are three nutrients, that is NPK, nitrogen, phosphorus, and potassium. These are supplemented through chemical fertilizers. But these microorganisms have the ability to fix the naturally available nitrogen, that is rhizobium, which modulates the pulses, will fix the naturally available nitrogen into the soil. Then azospirillum, azotobacters, and we have pseudomonas also, which is known to mobilize the nutrients in the soil. Then we have something called as green leaf manure. What does this green leaf manure means? Green leaf manuring is a technology where we use leaves of few plants like sesbania, then we have diancha, then we have sun hemp. So all these in Kannada we call it as gobrada gida, that is eupatorium. That can also be used as a potential alternative to the chemical fertilizer. Then we have biomanagement. What does this biomanagement mean? All my friends, you must be aware that crops are attacked by a varying number of pests and diseases. To control these pests and diseases, and also farmers go for very costly and hazardous pesticides and weedicides. To overcome this, we have something called as biopesticides. What are these biopesticides? Biopesticides are basically predators and parasitoids. You're well known about the food chain. In food chain, we have the food, we have the predator, we have the prey. So this biomanagement or natural farming on that principle, where we use the naturally available predators and parasitoids to control the pests and diseases. And also, as already mentioned, trichoderma and pseudomonas are also, trichoderma is a fungi, pseudomonas is a bacteria. These can be used to control other microorganisms. They predate on other disease causing microorganisms, and thus reducing the dependency on chemical pesticides and chemical weedicides. Then we have something called as vermicomposting. Vermicomposting, my dear friends, is a technology wherein we use the earthworms to convert or recycle the agricultural waste into manures. So earthworms like we have Acina fetida is one of worm, and even African earthworms are very efficient in converting the agricultural waste into manure, which can be used to fertilize the crop plants. So these are all the few of the components of organic farming. There are other components like you can use crop rotation for that matter to control the pest. And there are other various components under organic farming, but any component which violates these 4 rules cannot be considered under organic farming. And nowadays people are ready to pay good amount for organic products. You might be knowing that people are getting aware, and they are going for the quality rather than nowadays. So millennials are much more aware of their health. Therefore organic farming is taking up pace. As I already said, organic farming is not new to us. It's like Dayananda Saraswati of IRS Samaj who said go back to Vedas. So it's like we are going back to organic farming, which holds the key. The only drawback is it's like Ayurveda. Organic farming is like Ayurveda, while chemical farming is like allopathy. In Ayurveda, the results are after a long time. Same in case of organic farming. Organic farming yields, they say, are less than chemical farming. Scientists have proved that over a long period of time, organic farming yield are equivalent to the chemical farming yields. So organic farming holds key to the sustainability and the future. Then we have something called as integrated farming systems. Integrated farming system is a combination of all farm components in such a manner that it gives maximum efficiency and returns. In simple words, IFS means diversification of farm enterprise. For example, if a farmer is having 1 acre of land and is going with the monoculture and monocropping of growing only paddy, IFS system incorporates other components of farm diversification, like that of the animal husbandry or beekeeping or silkworm, which will help the farmer to gain additional income or minimize the loss. So the another major concern in farming is like crop loss or non availability of suitable price. In such case, integrated farming system will help the farmer to overcome such flaws. So what is this integrated farming system? So these are all the components under integrated farming system. That is, we have the field crops, that is cereals, pulses, oilseeds, and commercial crops. That also covers crop production, vegetables, fruit cultivation, poultry, livestock, duckery, aquaculture, agroforestry, beekeeping, mushroom cultivation, and biogas plant. These have to be incorporated into a single farm so that there is a nutrient recycling and the raw material exchange between these components only. That's the idea of integrated farming system. We have a KVK in Brahmavara, which has come up with a very good model called as Krishi Brahmanda. Krishi Brahmanda is a model wherein in 1 acre of land, farmer can incorporate all these and get the additional benefit over the traditional monocropping or the monoculture what the farmer is practicing. Here I want to give a small example of how this integrated farming works. See, here you can see there's a chicken shed on a elevated platform below which farmer farming. Here the advantage of this is the feces or the waste of the chicken naturally becomes the feed of the fish. Therefore, farmer saves the money which he uses on the fish feed. Dr. A.M. Ramesh is from fisheries background, so he might be knowing that the cost of cultivation of fisheries, which actually accounts for a lot. So the crop economics can also be managed because of integration of such novel technologies. Also, a farmer who is growing paddy can easily incorporate a mushroom cultivation unit. Mushroom cultivation, it requires just 10 by 10 dark room the mushroom cultivation, and the paddy straw which he gets acts as a natural substrate for the growing of mushrooms. And we know how mushrooms are economically superior when compared to other farm produce. So here there is a chart where there is a nutrient cycle, forage crops, crop residues, and the livestock production. So this is how the integrated farming system works. This has to be popularized among the, it's like it's already there, it has to be popularized among the farmers. Then we have something called as hydroponics. My dear friends, I already said I stressed on the point that the land availability is 158.7 million hectare. I stressed because that land is going to be stay the same, but our population is growing at an exponential rate, or I can say it's growing at GP, while our land is at same. So other possible technologies to reduce, there is a huge pressure on land to feed the population. Therefore, to overcome this, there is a technology called hydroponics, which is cultivation of crops in soilless culture in a nutrient-rich medium called the Haberland solution. Haberland is the scientist who gave this solution, which is the nutrient-rich medium. Basically, the concept is the role of soil in crop production is supplying the nutrient to the crop. So that can be done through the Haberland solution. Therefore, in soilless culture or nutrient-rich medium, we can grow crops. So this overcomes the limitations of soil cultivation and also the land constraint. As I already said, the limitations of soil cultivation and also the land constraints can easily be overcome by this hydroponics, growing of cereals as feed for the cattle. Here we took a hands-on training during my UG campus, where we grew maize in hydroponic unit, and we were able to successfully manage dairy unit of our farm for 15 to 30 days with the hydroponics feed which we grew. Here you can see our dean and honorable vice chancellor of University of Agricultural Sciences Bangalore, who visited and appreciated our effort of hydroponic unit. So this can be practically done. This is what we were taught through this hands-on training module. Then we have something called as hydrogels. So what are these hydrogels? Hydrogels are actually a network of cross-linked polymer chains with a 3D structure which has water in dispersion medium, thus can swell and hold the water. My dear friend, these hydrogels are already available in chemical engineering and other polymer industries for water soaked and other related materials. They're using these hydrogels. Now, research is going on whether these hydrogels can be used for agricultural purpose. In agriculture, these can be used for reducing the loss of nutrients and increasing the water use efficiency. Water is not a constraint for people in Mandya and Hassan because they are blessed by the river Kaveri. But there are other districts in Karnataka like Koppal, Gadag, Raichur, and Gulbarga for that matter, where water is a very major constraint. And dry farming or dry land farming is a major in the district which I mentioned. Therefore, these hydrogels can be used there to improve the water retaining capacity and slow release of water, which will also help in reducing the loss of nutrients and increasing the water use efficiency. So these hydrogels are also now being popularized, or the research is going on to make them economically viable, to make sure the water use efficiency of the farm is made more. Then you have something called as aeroponics. Aeroponics is similar to that of hydroponics, but the only difference being that instead of Haberland solution, we are using an air or mist environment without the soil or an aggregate medium. So practical application of aeroponics can be, the research is going on, whether we can produce the potato tubers, and it's like almost it's successful. So why potato tubers in major? Where I studied, that's Hassan. It's the major district contributing for the potato production. And you must be knowing that potato tubers are not formed in Karnataka because the potato seed is not produced here because of the agroclimatic condition. Every year we have to import the potato seed in the form of seed tubers from Kufri in Shimla and Punjab, where there is very cool season and temperate season. To overcome this constraint, research is going on whether potato tubers can be cultivated under the aeroponics, under a controlled condition, whether potato tubers can be produced, so that it will be a boon to the farmers of Hassan who majorly depend upon potato cultivation. That's how aeroponics, the recent research trend, where the potato tubers which we used to take from import from Punjab and Himachal Pradesh, and many a times we were getting very low grade or not so good seed tubers. We are able to produce it here only in Karnataka under controlled condition. That's the beauty of aeroponics. We have remote sensing and geoinformatics, as rightly mentioned by Dr. A.M. Ramesh. These are taking place nowadays. So what's remote sensing? Remote sensing is a geospatial technology based on satellite data. And it is used for, and what are all the possible application of the potential application of remote sensing are, it's used for weather forecasting, water management, soil studies, and also for disaster management. How basically this remote sensing and geoinformatics work? As we already know, there are various communication satellite and IRS satellites launched by ISRO, Indian Space Research Organization, which continuously orbits the Earth. They continuously send the data to our station, which can be used for the benefit of farmer. In this regard, I would like to mention that there is a new scheme by government, that is Mausam Seva, e-Mausam Seva, which through the agromet labs, that is the agrometeorology labs, farmers are being given the crop advisory based on the weather forecasting, which in turn depends on the geoinformatics. So this is how remote sensing is being used for the benefit of the farmers at a macro level. And at a micro level, it can be used for the water management. Recently, ISRO conducted a certificate course on application of remote sensing in agricultural water management, where I learned that application of remote sensing hugely helps in water management, because through remote sensing and geoinformatics, we were able to analyze the available soil moisture in the soil profile. Based on the available soil moisture in the soil profile, we can schedule our irrigation, thus reducing or efficiently using the water. Water is also a very major constraint in agricultural production. Then soil studies and also disaster management. How does soil studies help? My dear friends, a large amount of Indian soils are affected by either acidity or alkalinity, or other or subjected to land degradation. These studies or mapping can be done using the remote sensing and the geoinformatics data. This is how remote sensing is helping the farmers unknowingly. Then remote sensing also helps in crop cutting experiments and loss analysis. So what is this crop cutting experiment? Crop cutting experiment is a prediction model. Like they take a 1 square meter or 1 unit area of how much that will yield, how much a unit area will yield. Based on that, they are going to predict the yield level of the crop over a larger area. That's how remote sensing can be used. And another major application is crop loss analysis. So there is a crop loss because of various biotic and abiotic factors. In analysis of this crop loss also, remote sensing is helping. There is a new yojana called Pradhan Mantri Fasal Bima Yojana, which is basically a crop insurance. To claim the crop insurance, we have to know how much crop loss has been occurred. To understand this also, remote sensing and geoinformatics is being used. And even ISRO has a separate department for agriculture and soils, where there is a continuous research going on in ISRO IIRS Dehradun, Indian Institute of Remote Sensing, which is based in Dehradun. They have a separate department for agriculture and soils, where there is extensive research going on in application of remote sensing and geoinformatics. Then we have this IoT, Internet of Things and cloud-based technology. So what does this IoT offers is it offers the smart solutions for farm problems. Today is the age of gadgets and devices, and everything has become smart. So why not agriculture become smart is the question which has been answered by Internet of Things. It includes agricultural drones, sensors, and electronic gadgets. In this regard, the agricultural engineering students from Raichur have developed a prototype of agricultural drone, which is yet to be patented, which can be used in application fertilizers, pesticides, and also scheduling the irrigation in the farms. So how does this help? My dear friends, another major constraint or concern in today's agriculture is that of the non-availability of labor force. Because of migration and urbanization, people are moving away from the rural India, which is causing a severe lack. So that issue can be monitored by the help of drones and even sensors and electronic gadgets. In our University of Agriculture Science, Bangalore, Department of Agricultural Entomology, has come up with a new software called ESAP. ESAP stands for Electronic Solution for Agricultural Problems or Agricultural Pests. So when a farmer brings a specimen, this ESAP will help him to understand the problem and also gives the electronic solution for the problem brought by the farmer. So these are all the new technologies which are around now. And our survey says IoT devices in agricultural industry will reach 75 million by this year. So IoT is also taking so much of pace in agriculture, and even farm universities in Karnataka are considering IoT and artificial intelligence in agriculture as the way ahead, and a lot of amount is being pumped in the research of IoT and artificial intelligence application in agriculture. Then we have something called as precision agriculture. So what is this precision agriculture? Precision agriculture is also called as SSCM or SSFM, that is site-specific crop management or site-specific fertilizer and nutrient management, which basically work with the help of GPS. We know what's GPS, Global Positioning System. So with the help of this, and we have something called as VRT, Variable Rate Technology. So what is the goal of this precision agriculture is to define a decision support system. Farmer, the precision agriculture gives a decision support for whole farm management with optimization of returns on inputs while preserving the resources. So what this basically does is it takes care of the individual crop unit area and gives the advisory to the farmer to what to do. My dear friends, farm is not uniformly is not uniform at all. There is nutrient deficiency somewhere, there is nutrient excess somewhere, there is water stagnation somewhere, there is no water at all somewhere. So with precision agriculture technology, farmer is being to able to address the site specific crop requirements. By doing such, he's actually saving his money and also time. Therefore precision agriculture also holds a lot of scope and potential within itself in the form of variable rate technology in the near future. Then we have nanotechnology. Nanotechnology is not new either to the science or to agriculture, because nowadays application of nanofertilizers and nanopesticides is taking so much of boom and gain. IFCO, the Indian Fertilizer Cooperative, is releasing its nano urea soon, by next year or the year next. Now it's under the field trial. There's the nano urea and also nano pesticides, slow releasing chemicals. What basically these nano fertilizers or nano pesticides do, they are slow releasing and more efficient. When the size gets reduced, obviously the efficiency will be more, and that's how the nanotechnology is playing a very major role in agriculture nowadays. And the future is surely very bright for nanotechnology and nanobiotechnology. And other things are nano devices for measuring water holding capacity and moisture content. As I already said, precision agriculture or smart agriculture, very nano or small devices for measuring the water holding capacity of the soil. These chips or sensors will give a clear picture of how much the water is there in the soil and how much has to be supplemented through the irrigation. And that's how nanotechnology is playing its way ahead. And other components of nanotechnology are also that is nanofertilizers, pollution sensors, water filters, nanobiocides, soil conditioning monitors, and even pharmaceuticals are also are the possible application of nanotechnology. But when we come to agriculture, even in food packaging and post harvest technologies are also nanotechnology is playing a vital role, where we are able to pack the food producers in a very efficient manner through the nanotechnology. Then we have something called as crop modeling. What's a crop modeling? Crop modeling is a novel technique of presenting the quantitative knowledge of the crop in a form of a model. It's basically a mathematical algorithm helping in precise estimation of the outputs. As we know how the computer languages, C language or C++ or Java works, it works on a basic mathematical algorithm. So that when we put into agriculture, it becomes a crop modeling experiment. So based on this crop modeling, we are able to predict the precise yield, crop improvement and crop protection measures which we have to take at the farm level. So this is how crop modeling is helping us to understand the various factors involving the crop and the crop microflora and macroflora. Then we have something called as biofortification. Recently, on the day of National Nutrition Day, our Honorable Prime Minister Modi dedicated 17 new biofortified varieties of around 8 crore nations. So what is this biofortification is? So biofortification is a technique of breeding of crops for nutrient-specific foods. We all know another major constraint today in urban India and also rural India is that of malnutrition or undernutrition, or which we call it as hidden hunger. The precise term is hidden hunger. Although we are getting cereals, we are self-sufficient, but we have the food security, but we don't have the nutritional security yet in rural India. To address the nutritional security, this new technology has come, which we call biofortification. Biofortification is breeding of crops for nutrient-specific foods. Department of Genetics and Plant Breeding, GKVK, has released a rice variety called Paustik. It has 14% protein, whereas normal rice has 6 to 8% of protein. But this Paustik rice has 14% of protein. Also, we have golden rice, which is higher in vitamin A. Then we have something called as iron enriched carrots. We have zinc enriched wheat. So these are all the few examples of new crops which are coming with biofortification. So this is also a very potential tool, or the research is going on to make sure we give the nutritional security to the masses of majorly lactating mothers and also pregnant women who are facing a challenge of malnutrition and undernutrition. Biofortification holds the tool as a solution to these problems. Then we have something called as biochar. So what's biochar? Biochar is basically a half burnt charcoal, which when applied to agriculture field, it's called as a biochar. So what does this biochar basically do? So biochar helps in improving the organic carbon water holding capacity of the soils. So this biochar can be applied to improve the organic carbon and also the water holding capacities. Basically, soil is a colloid. So there are various colloidal properties associated with the soil, which is influenced by application of this biochar. So and even biochar is a very important or tool to combat the waste recycling or the waste management techniques in agriculture. So this is biochar for you, which is a half burnt coal, which when applied to agriculture fields increases the organic carbon and also the water holding capacity. Then we have something called as biofuels. Biofuels is not new. Research has been taken since the 2000s, but yet it has to be popularized. Biofuels are plant-based fuels which can be used in or as a supplement with them. So you know about biodiesels, ethanol from sorghum. So there is a biofuel park also established under university in Hassan, where research is going on validation and application of various tree BOs. We call them as TBOs, tree-based oilseeds like Jatropha, Pongemia, Calophyllum, and even sweet sorghum. So Pongemia, now Kannadalli honge mara anta ಏನು ಕರಿತೀವಲ್ಲ, so that is Pongemia. Then Jatropha. These the seeds or the seeds of these trees can be used, can be extracted from them and can be used to run our engines. So this is a green technology, I can say, or it is a renewable technology which will ensure sustainability in the future to come. So Brazil tops in biofuel production. It's a world leader, I can say, in case of biofuel production. India, still the pace has to be taken up. So there is a wonderful opportunity for research in case of biofuel also, and the government is also giving a huge subsidies and supporting like biofuel and other green technologies as such. So these are all the techniques or the strategies which hold the key. Now let us see how agriculture sector has grown through the ages in the modern era, from subsistence to subsistence. Subsistence is growing for ourselves, like we grow, we eat, that's it. That was agriculture for a long period, but the scenario has changed. Today there are large number of agri-tech startups coming, and also startup is building in agriculture. So Indian agriculture has grown as a potential area for startups. See this, according to a NASCOM study, India accounts for over 450 startups in agriculture space, and they raised nearly $248 million until June 2019. Isn't that wonderful, my dear friends? Even agriculture is giving potential startups and agri-tech startups in the field of agriculture. So we know Bangalore, being the leading hub of startups in the country, offers a great opportunity for agricultural startups. And there are there is a lot of scope for startups in agriculture, because we have a lot of problems. Where there are a lot of problems, there startups come as a solution for that. Therefore agriculture has a lot of constraint, or I'll not rather than calling them problems, I can call them as challenges related to fair price to the farmer, or connecting the farm to the markets, or right time agro crop advisories, or giving right agricultural inputs for that matter. So there are agro input, supply chain management, quality control, quality assurance. There are so many areas in agriculture where startups can be taken, and Bangalore is leading the country with an example. Also agricultural startups are also taking place in Bangalore. So it's a great initiative of young minds or the millennials setting up startups. Here are a few of the example of successful startups in the form of Ninja Cart, AgriHub, Krishi Star, AgroStar, we know, Cropin, and you can even Biocon for that matter by Kiran Majumdar Shah. But there are various startups in agriculture, and even corporate sector are also donating huge, pushing huge money into agricultural research as well. So this was from subsistence to startups. Then we have something called from migration to micro entrepreneurship. What does this mean? Uh, Mahatma Gandhi said India lives in our villages. So urbanization is not a answer to the rural problems. We have to strengthen the rural economy. We have to strengthen rural India so that it becomes self-sustainable to solve its own problem. The solution for rural India is not urban India as such. Therefore, there has been a shift on rural development in the field of agriculture, where farmers are now being considered as entrepreneurs. Farmers are also entrepreneurs. They are taking venturing into various aspects of agricultural diversification, I already said. So that perspective of farmers being farmers as that hungry person who is toiling or working hard all the time in the field. No, the scenario has changed. Now they are micro entrepreneurs in a small scale, in 1 acre of land or 2 acre of land. So that's how agricultural entrepreneurship can help tackle the challenges related to information dissemination, farm management, capital availability, farm mechanization, agricultural supply chain. So this is what happening nowadays. Farmer is also being treated as an entrepreneur. So creating more industry in the urban area for migrating farmers cannot be a solution, as already said. So there is need to bring about transformational changes in the agricultural sector by encouraging the micro entrepreneurship. That's what is happening. Then at last but not the least, from Pusa to Pura. Many might be wondering what's Pusa. Pusa is the first agricultural institute which was established in India with the help of Rockefeller Foundation in America. Pusa stands for Pips from USA. He was the person who incorporated the Pusa Institute in Bihar, which was then shifted to New Delhi. Till today, also the leading agricultural institute in India is Pusa Institute, that is Pusa New Delhi Indian Agriculture Research Institute. From there, India has to move towards Pura, that is the concept of J. Abdul Kalam, which is providing urban amenities to rural areas. That's how I end. There is a lot of opportunities in the field of agriculture, and its actual potential is yet to be tapped. And as I already said, for the past 10 years, we know the art of 10,000 years, we know the art of farming. And for the next 10,000 years to come also, agriculture is that sector which will give food and provide everything which a person needs. So I would like to end by quoting Pandit Jawaharlal Nehru, who said, "Everything else can wait, but not agriculture." Thanks for the patient hearing and for this opportunity. I rest my speech. Thank you very much.
You are a very good communicator, Abhishek.
Thank you, ma'am.
Hearty congratulations, Mr. Abhishek. Your talk was wonderful. You covered everything in agriculture, leaving nothing to others to speak. Excellent speech. Good. Keep it up. God bless you in your pursuit for higher studies. All the best for you.
Thank you, sir.
Wonderfully spoken. Wonderfully spoken. Really, I thank you for overtaking me, both the chief guests. Actually, agriculture gives us food, and Mr. Abhishek Kulkarni has given me food for at least 1 month now to browse about all these new concepts which I had not thought that much of. It may be from hydrogels, or it may be Pradhan Mantri Fasal Bima Yojana, or it may be Nano Urea. And there are a lot of things which we need to know more about, and very well spoken. Thank you so much, Abhishek Kulkarni. It was really wonderful. We surely gained a lot of knowledge through this particular session. We keep the we keep the session open for questions now. Uh, there has already been one or two questions which has come up. So I will start away with one question. So before that, I request the audience kindly do not exit. We will be sending across a Google form link so that you can avail the certificate. decades by the end of today's event. So, Abhishek, when we hear about Bacillus thuringiensis, many of the scientists start getting afraid of what the consequences would be after the research is over. So, the BT cotton it started from, and probably the BT brinjal was one of the greatest wave of opposition which India faced. I still remember it during my high school age. BT Brinjal Go Back was one of the placards which were held in many streets of India. So Meera ma'am has asked whether this, uh, no, the opposition to this BT Brinjal or BT products, is it because of political pressure or is there any scientific reason for it?
I would say partly both. Both what you said are reason for this. When BT cotton came, there was a drastic reduction in the consumption of pesticides, and there are lot of companies which are there in the pesticide market also. But eventually, for their surprise, after a few years, the pesticide consumption went up because the minor pest of cotton became the major pest of cotton, because the we controlled the bollworms, but the leaf suckers, like the sucking pest, became more. So I would say the concern regarding the BT or the GM crops is both scientific also and political also. I would like to quote here the what happened in USA. Recently, I was going through a research paper where introduction of GM crops has had a negative impact on the bees there. Honeybees, which are very important pollinator and also very important component of for our pollination of farm field crops also. So I think there are also few scientific concern. Yet they can be answered through science only. So what are all the arguments are there scientifically can be easily identified and answered through science. And when there is no opposition from from there is no any constraints in USA growing BT corn, I don't understand or see any scientific reason for opposing GM crops. And that's why, as I already said, BT brinjal trials has now begun. GEAC, Genetic Engineering Appraisal Committee, has given its consent for the trials of uh, BT brinjal in farmers field. But I'm sure in the future GM crops will eventually come in the way of for in our, it will be on our table soon.
Great. So one more question which is arising in my mind now. So as road tractors, many of us want to have the sustainable farming concepts in our houses. So through your experience in agriculture, which crops or which vegetables or fruits do you think we can grow in our houses, considering the limited space which we have in urban areas?
There's a con, I forgot that there's vertical gardening. It's taking up pace. Vertical gardening, and even the Department of Horticulture is also giving the kits, vertical gardening kits, which also have which can be used. For that question, you can easily grow leafy vegetables come within 15 to 20 days. Fresh leafy vegetables can be grown in your home backyard or in the apartments through vertical gardening concept. And even a very good strategy to recycle your own kitchen waste. The kitchen waste can be recycled through growing of leafy vegetables. I think green leafy vegetables can be easily grown in your backyard or sorry, or in your apartments in vertical gardening concept, because they come within 15 to 20 days is enough for them to harvest it.
We had Rotarian Vincent Raj sir with us. I guess sir has just exited from the event. I wanted to ask sir to gain a little knowledge. So Vincent Raj sir, as far as we know, is one of the person who owns a ostrich farm in India, and that is in Hassan. So Abhishek can catch hold of sir and conduct some study over there. So speaking of which, what do you see are the research which is taking place in the poultry farming related aspects? Because we know this bird flu is one which arises every once in a year, and there is a great loss to a lot of farmers. So people are afraid to take it up.
Actually, poultry and dairy sector, for that matter, are vital for rural population. That too in a place called like Hassan, because they are very non-veg, like loving people in the parts of Mandya and Hassan. The concern regarding bird flu, which you said, is actually very alarming. But there are many. There are in even in veterinary sector also there are advents and research which is going on, and poultry can be taken, and even ostrich farm, as you said, can also be a very good example for agrotourism. Even agrotourism is catching up pace nowadays. So ostrich farm or in that can be taken up as agrotourism initiative also. And the regarding the concern of bird flu, it's there, but it's not permanent. It's like just a temporary. The flu will just like COVID-19, it will get over, and poultry can be taken as a very good initiative by the farmers. In this regard, I want to say there is a new breed called Kadaknath. Kadaknath is a new breed of poultry where the flesh is black, the bird is black, the blood is black, so everything is black in Kadaknath. So that's also recently taking place. Kadaknath, even they say even the egg is also black, but I have not seen any black egg till now. But that's what the trend in poultry farming. Regarding this bird flu, no need to worry. Poultry can be taken up.
Great. So I
Excuse
have last.
me.
Yes, ma'am. Yes, ma'am.
Your own Giri Raja,
Giri
is it
Raja, yeah.
still there or gone?
Yeah, Giri Raja is there, ma'am. From KVK Hassan also they are giving Giri Raja. The problem with Giri Raja was actually all the farmers believed that Giri Raja will give good returns and took it, and there was a problem for marketing it. Like after a few days,
Oh.
nobody was able to take it. Even from our KVK Hassan, they gave Giri Raja to many farmers, but Giri Raja is still there. Good meat yielding.
My husband's batchmate Ram, he was a developer.
Oh wow, happy to know, man. That has actually brought a lot of money to the farmers
Yeah.
who reared Giriraja. But my practical experience was like in KVK Hassan they were giving this Giriraja, and after 40 days they were coming to KVK to sell. So that there was a small decrease in the market, but yet it's most sought out by the farmers.
Okay.
So we used to remember Rotarian Shankar sir, who was the fifth batch alumnus of University Agriculture Science 1953 batch. His contribution to the field of agriculture is also immense. So the next question, which I have in which I have been asked by our Joint Secretary Dr. Akshat is, as engineers, what contribution can we take up or we give to the field of agriculture?
This Internet of Things, this drone technology was which I said, and although among the out of 450 startups, like majority 80% are from engineers only. So there is a lot of scope for engineers in field of agriculture. As I already said, bringing the IoT or Internet of Things is because of information technology, software people only. So they can help in solving the problem, problem of farmers. So engineers, you please look up to the problem of farmers. So you come up with an idea. That's how innovation or that's how research starts. So even engineers are of very vital importance in field of agriculture. So as I already said, even we have farm machinery. So crop harvester we have, processing we have. So they can take up research or study in that how to ease the, because agriculture requires lot of labor. So as I already said, to reduce the labor, if you can come up with farm equipments or any other technology which will reduce the stress on farmer, the area is open for you. There is a huge vast area open for agriculture engineers in the field of agriculture, because engineers always outgrow their boundaries and venture everywhere. So agriculture sector is always open for that also.
It is a
Uh,
sharp mind and they start dreaming.
Yeah.
Education sharpens your mind, thinking. You can go to any field.
It seems in many of the startups in agriculture are owned by engineering graduates,
Yeah.
more
Good,
than
good.
agriculture graduates.
Yes, yes.
Nice. One last question to you, Abhishek. So this is out of curiosity I'm asking. I should have asked my cousin who introduced you to me. Even he is started mushroom farming in our native. Known to be vegetarians, we were very away from mushrooms for a long time. But now it is very special for us to take up this mushroom farming in our native location. But I've heard that the yield is great and the entire process is also wonderful. So can you give a very small description about this? Why is there such a increase or interest in mushroom farming among many farmers?
This is because of Chinese food, the gobi manchuris and noodles and those mushroom. They use mushroom. So I rightly said, my friend, your cousin, he's from Mangalore, no? So even that place is ideal for the humidity and all is ideal for mushroom cultivation. Yet the increase in mushroom cultivation is also because of the fact that there are many cancerous elements in mushroom. So it is known to cure few cancer also, and protein and other vitamin content is also higher. So as you already said, vegetarians, we don't eat, like people don't eat meat. They lack vitamin B and other very vital nutrients which can be supplemented through soya bean and mushroom. So that health concern is also because reason for increase increased demand for mushroom. But farmer can easily take up it, and even 10 by 10 room, a dark room preferable, and with humidifier is enough to take up mushroom cultivation. It is taking like it's slowly taking up pace, and even KMF for that matter, the Nandini brand we have, Karnataka Milk Federation, is also giving few initiatives and subsidies for the cattle farmers who are taking up the mushroom cultivation. To be on brief, there are oyster mushroom, pearl mushroom, milky mushroom, and button mushrooms. All you need is a mother spawn. Spawn is available at Agriculture University. That can be taken, and paddy straw is required, which has to be sterilized. And in a bag, if you put the paddy straw and the spawn and give optimum condition in form of dark condition and optimum humidity, you can get a wonderful harvest of mushroom. 1 kg of mushroom is costing now 250 to 300 rupees. Which will surely, within a short period of time, farmer can get a handsome amount of money in his hand.
That was really wonderful. A lot of knowledge we have acquired by the end of the session. I was sitting and just noting down the points, and I was thinking there's a lot for us to go through in the field of agriculture. Our past president says he has a question on bee farming. We will take it up, and this will be the last question. Krishnarjan, I'll be making you the co-host. Please.
I think it was fantastic having Meera ma'am as chief guest and a brilliant session overall. My question on bee farming.
Krishna, can you use the mic close?
Yes, thank you. Okay, so my question on bee farming is, can we do organized bee farming? Recently, when I had come to GKVK, I realized that with an investment of close to 4,500 rupees, you can get a bee
Bee
farming
box.
set, bee box, exactly. So if we are able to do it in a very organic and organized way, can we have the collection being done, and imagine Rotary and Rotaract coming together to get many of these farmers empowered with this kind of kits, with training as well as with these kits? Will we be able to procure a good amount of honey and make it a viable business option for farmers?
Yes, sir. If you do it like very organized way, it's you can get a good amount of honey. Way back 10 years ago, apiculture, which we call as a bee culture or apiculture, was confined to areas of Western Ghats like Sakleshpura, Alur, and all. Today, even Chitradurga farmers are taking up apiculture or honeybee cultivation. Surely you can do, but only concern is that bee requires bee flora. That is, they require flowers or plants or crop, even grass species. They require nectar and pollen. That's what bee demands from you. with a prior knowledge, because there are various honeybee subspecies like Apis dorsata, Apis serena, Apis florea, and Trigona iridipenis. There are various species. So with prior knowledge, and it's location specific, I can say, sir. Like if you want to take up it in urban areas of Bangalore, I'm afraid you'll not get a good this thing. But outskirts of Bangalore or anywhere where there is plenty of flowers, or there is a bee flora, you can easily take up agriculture in a organized or a planned manner, with the prior knowledge of how bee morphology and how bee behaves, and you can easily take up apiculture or bee farming. Should be, they say, as busy as a bee. So if you that honeybee farming, you can take up. All the requires flowers, pollens, and nectars.
Perfect. I think the project name can be make money through honey and get
Yeah.
maximum people to engage. Yeah. Thank you so much, sir.
Thank you, Krishnarjan. Thank you, Abhishek. It was really wonderful, a wonderful presentation. There are lots of appreciations coming in through the chat box, and I'm pretty sure that you will now on be invited for many Rotary and Rotract sessions as a speaker. And I'm pretty sure that RCBS will not let you go that easily. We'll be having a series of sessions on agriculture, and we will be inviting you over to learn more, so that we who are here in the urban will get to know a little more about agriculture. As you said, we are not the problem solvers of the rural India, but at least let us give a small helping hand in whatever changes that could be brought. So,
Sure, sir. Thank you, Professor Srinidhi. I'm indebted to you for introducing me and giving me a chance to speak in front of stalwarts like Dr. A.M. Ramesh and Mirabai Shankar, ma'am. It's a very
Yeah, I am
privilege.
not a scientist.
No,
My
ma'am, you are a
husband was a
stalwart.
scientist.
No, you are a stalwart in your field. So for that matter, I'm very thankful to you, and I'm very thankful to Dr. A.M. Ramesh sir and Mirabai ma'am and all the other office holders and office bearers of Rotary. Thank you very much for giving me this opportunity and listening to me. Thank you. Thank you, Professor.
thank you so much, Abhishek. I now invite once again our President, Road Tractor Lavanya, to give the vote of thanks. Lavanya, let me give the co-host access to you. Yeah. I guess there's some technical issue. Yeah, okay. Lavanya, I see you unmuted. Can you give the vote of thanks?
Propose, not give.
Am I audible, Srinidhi?
Yes.
Can I go ahead? Am I audible?
Yeah, please.
Thank you, Srinidhi. Well, I would like to express this gratitude, in fact, on behalf of, again, Rotary Club of Bangalore, Sheshavipur. I thank the speaker of the day, Mr. Abhishek Kulkarni, Agriculture Research Scholar, for such an effective session, really such an informative session since an hour, as it's a need of the hour as well. So I'm sure you all would have understood the importance of recent research in agriculture. I'm sure there's no doubt a consequence of greater intention of research in agriculture. So I thank, and also I would like to thank the chief guest, Dr. A.M. Ramesh, CEO of
Thank you
Karnataka
very
Science
much.
and Technology Academy. Thank you, sir. Thank you for your
Yeah.
valuable time with us today. Looking forward for more such initiatives with your academy, sir, in
Yeah,
upcoming
please.
days. Well, I make a sense of appreciation to our young and energetic club advisor and trainer, Rotarian Mirabai Shankar ma'am. Thank you so much for joining, ma'am, and sharing your views and thoughts regarding this agriculture. Thank you so much, Mira ma'am. Seeing and spending time with you is a energy booster, ma'am. I'm sure everyone here would agree me. Um, I thank the guest of honor, Dr. Balasubramanian sir, who is along with us in the beginning, and would also like to thank supportive for this project and Vishnu. And Dr. Srinidhi, thank you so much, Srinidhi, for commencing this program, and thanks for connecting us with Dr. A.M. Ramesh sir. And also would like to thank the project's chair, Rotractor Akash, and coordinator, Rotractor Manasa Gowda, and the team of Project Anveshana for organizing this wonderful session. And also would like to thank Joint Secretary Retractor Rakshit Shetty. And I would also like to thank the past presidents, past President Retractor Nishit, past President Retractor Krishna Arjun, past President Retractor Apurva. Thank you all for joining and sharing your views. And I would also like to thank all the presidents and secretaries of other clubs and directors and members of Rotary Club of Bangalore Shishadipuram. And I would like to recognize, and I would also like to thank the Hasiru Committee Chair, Rotarian Retractor Manjunath Nag. Thank you for joining. And I would also like to thank other presidents and secretaries of other clubs, members of RCBS, and to all my fellow retractors, non-retractors. Thank you all for joining this session. Thank you so much. Thank you all. Have a great day ahead.
Thank you very much to all. Thank you.
Thank you, President. Thanks to you too. And once again, my hearty gratitude to Karnataka Science and Technology Academy, Dr. A.M. Ramesh sir, and Royal Concord PU College for collaborating with us. Many more sessions to go. We will meet once again in the next month with another topic. And until then, thank you all. Thank you so much.
Thank you.